Hello everybody, welcome to my new video. In this video, I'm gonna show you how to balance any chemical equation, and also I will show you how to write a formula and chemical equation for a given reaction. I have 5 questions in this video. In question A, let's read the question. Question A, magnesium and hydrochloric acid react to produce magnesium chloride and hydrogen. First of all, we must convert this sentence to formula equation. For this reason, we must be familiar with correct symbols, correct formulas of the reactants and the products given in the reaction. In this reaction, magnesium reacts with hydrochloric acid and they produce magnesium chloride and hydrogen gas. Okay, here there is no state given for the both reactants and the products. For this reason, no need to state any state or substance in this question. Okay, let's start to solve this question. The symbol for magnesium is Mg and means plus. Magnesium reacts with hydrochloric acid. Its formula is HCl. To produce means you show it by an arrow. Magnesium chloride. Magnesium, its charge is +2 and chloride is Cl minus. You cross over the charge by taking the absolute values, then you get MgCl2. This is magnesium chloride, MgCl2. And hydrogen. Hydrogen is shown by H2 because this is a molecular element, diatomic molecular element. Its formula is always will be H2 plus H2. As you see in my formula equation, this is the formula equation. It is not balanced chemical equation. For this reason, we must balance this equation. But how can we balance? This is the problem. We're going to use the proper coefficients. For magnesium, I have one magnesium atom on the left side of the arrow, one magnesium on the right side of the arrow. And I go on with hydrogen. I have one hydrogen on the left side of the arrow and two hydrogens on the right side of the arrow. So if you write 2 in front of hydrogen as a coefficient, as you see now, I have balanced number of hydrogen atoms on both sides. By the way, I realized that my chlorine atoms on both sides automatically balanced. So this coefficient 2 belongs both hydrogen and chlorine in this formula. So I have 2 hydrogen atoms and 2 chlorine atoms on the left side, I mean on the reactant side, and I have 2 chlorine atoms, 2 hydrogen atoms on the product side. So this is a balanced chemical equation. Okay, let's continue with question B. Aqueous nitric acid, I'm writing, look here, state for nitric acid is given. Nitric acid is HNO3 and its state is aqueous, shown by AQ next to the subscript. Reacts with means plus. Solid magnesium hydroxide. Look, magnesium, its charge is +2, hydroxide OH minus. You cross over the charts, it becomes MgOH2. Of course, it's a wrong formula because if the charge of the cation is bigger than 1 and if your compound contains a polyatomic ion, then your polyatomic ion must be put into a parenthesis like this, as you see here, MgOH2 by 2, MgOH by 2, okay, MgOH by 2, and its state is given here. It is solid, shown by S. To produce means arrow. Aqueous magnesium nitrate. Magnesium 2 plus. Nitrate is shown by NO3 minus. Crossover charge Mg. Open a parenthesis because the charge of magnesium is bigger than 1. Put your polyatomic ion into it and write this subscript of magnesium outside the parenthesis by taking the after taking the absolute value. Okay, the formula for magnesium nitrate is MgNO3, okay, N2. Its state is given aqueous, shown by AQ, and water plus H2 liquid. Okay. We're going to start to balance this equation. This is the formula equation. I haven't balanced this question yet. This is something like playing a mind game. You must see the proper coefficients for balancing. I have polyatomic ion groups here. Okay, on the reactant side, I have one nitrate group, two hydroxide groups, as you see. So it is very easy to balance nitrate groups because on the right side of the arrow, there are two nitrate groups. So if you write 2 in front of the formula of nitric acid, now as you see, nitrate, I have 2 nitrate groups on the left side, 2 nitrate group on the right side, and also I have 2 hydrogen atoms here plus 2 hydrogen atoms here. Total I have 4 hydrogen atoms. So if you write 2 in front of water as a coefficient, now number of hydrogen atoms has been balanced. And now we go on with counting oxygen atoms. I have 2 times 3, 6 oxygen atoms here, plus 2 times 1, 2 oxygen atoms here. Total I have 8 oxygen atoms on the reactant side. And also here I have 2 times 3, 6 oxygen atoms, and plus 2 times 1, 2 oxygen atoms on the product side, total 8. So I can say automatically my oxygen atoms have been balanced. This is a balanced chemical equation. I use 2 proper coefficients. In front of one is written in front of nitric acid, one is written in front of water, then you obtain your balanced chemical equation. And here also I showed how to write a correct chemical formula for a given compound in the question. Okay, let's go on with the new question. Solid sodium means Na and state is S. Combines with means plus. Chlorine gas. As I told you in the previous question, chlorine gas, like hydrogen gas, it's a diatomic molecular element. For this reason, its formula is always Cl2. Chlorine gas is shown by Cl2 and its state is gas. To produce means arrow. Solid sodium chloride. The charge for sodium in its ionic form is +1. Chloride is Cl-. You cross over the charge. After taking the absolute values, it becomes NaCl. NaCl is the chemical formula for sodium chloride, and also its state is given in the question. It is solid. Okay, let's count the number of atoms step by step. On the reactant side, I have 1 sodium atom. On the product side, I have 1 sodium atom. Here there is no problem, I think, with the number of sodium atoms on both sides. But the problem is with chlorine. I have 2 chlorine atoms on the reactant side, 1 chlorine atom on the product side. So if you write here 2 as a coefficient in front of sodium chloride's chemical formula, you will be balancing number of chlorine atoms. By the way, you are changing number of sodium atoms on the product side. So to balance number of sodium atoms on both sides, you must write 2 as a coefficient in front of symbol of sodium. Now it's a balanced chemical equation. 2 sodium, 2 sodium atoms. 2 chlorine atoms, 2 chlorine atoms here. It's very easy to balance this reaction. Okay. Let's go on with the new question. When solid copper means Cu, its state is S, reacts with means plus, aqueous silver nitrate. Let's write the chemical formula for silver nitrate. The ionic form of silver is Ag plus, nitrate is NO3 minus. You cross over the charges after taking the absolute values of the charges of the ions, and the formula becomes AgNO3. So plus AgNO3. Its state is given in the question. It's aqueous. It means it dissolved in water. And the products are arrow aqueous copper 2 nitrate. Copper 2 is the Cu2 plus, nitrate NO3 minus, cross over the charge, Cu, put your nitrate, it's a polyatomic ion into parentheses because the charge of copper is bigger than 1, and write the charge of copper after taking its absolute value outside the parentheses. So this is Cu NO3 by 2. And its state is given in the question, aqueous, shown by AQ next to the subscript, plus, and solid silver, Ag, only Ag. There is no charge in my chemical equation. There will be no charge in the chemical equation. Its state is solid. Okay. Now when I look at the formula equation, this is my formula equation for my chemical reaction. I see copper, copper, they are balanced. Silver, silver, they are balanced. There's a problem with nitrate groups. So I have one nitrate group on the left side, two nitrate groups on the right side. So write 2 in front of silver nitrate, and you will be balancing number of nitrates on both sides. By the way, you are changing number of silver. To balance the number of silver atoms, you must write 2 in front of Ag. Now let's count the number of atoms on both sides. Copper 1. I have one copper atom. I have one copper atom on the reactant side, on the product side. And 2 silver atoms on the left side, 2 silver atoms on the right side. And 2 nitrate groups, as you see, 2 nitrate groups on the reactant side. And as you see here, 2 nitrate groups on the product side. And as you see, this is a balanced chemical equation. Okay, let's continue with the last question. In a blast furnace, blast furnace is an oven used in chemistry laboratories. The reaction between iron 3 oxide, iron 3, Fe3 plus, oxide, O2 minus, cross over the charts. After taking their absolute values, your formula becomes Fe2O3. Right here, Fe2O3. And its state is given in the question. It is solid. And carbon monoxide gas, COG. This is binary molecular compound. For this reason, we use monoditritetrapenta. Both carbon and oxygen are nonmetals. And here there is one more information must be stated. When O and O, A and O are coming one after another in any naming of binary molecular compounds, first letter always drops. Like what? Monooxide becomes monoxide. Pentaoxide becomes pentoxide. Okay. They produce solid iron, Fe, S, and there is no Fe2 plus, Fe3 plus. Iron is an element, so elements do not carry any charge. And carbon dioxide gas, CO2G. Okay. This is my formula equation. Now we want to balance this formula equation, but this is a little bit hard to see which proper coefficients must be written in front of the formulas or the symbol. You must be careful. You must try some different coefficients to balance this chemical equation. As I told you, this is something like playing a mind game. Don't worry, everything is so easy if you are able to see the correct coefficients. Let's start with the iron. I have 2 iron atoms on the reactant side, 1 on the right side. So right here, 2 in front of iron, right 2. Okay. Now my iron atoms have been balanced on both sides, on reactant side and on product side. Okay. Then let's count the number of oxygen atoms. 3, 1. I have 4 oxygen atoms here, 2 oxygen atoms here. But if I write 2 in front of carbon dioxide, I will be changing the number of carbon atoms. So to balance number of carbon atoms on both sides, I must write here 2. It means, or it will cause us to change in number of carbon atoms. There will be changing number of oxygen atoms. I'm so sorry. So I must use a coefficient other than 2. Let's try 3. Okay, right here 3. I have now 3 times 2, 6 oxygen atoms, and 3 carbon atoms. And right here 3, please. Okay. And now let's count the number of oxygen atoms. 3 here plus 3 times 1, 3 oxygen atoms, 6 oxygen atoms. And 3 times 2, 6 oxygen atoms I have on the right side. So my oxygen atoms have been balanced. What are the carbon atoms? 3 carbon atoms on the product side and 3 carbon atoms on the reactant side. Balanced. 4 iron atoms, 2 iron atoms on the right side and 2 iron atoms on the left side. Okay, thank you for watching.